Okay, the second part, okay, information of complex compound, okay, is bonding of complex ion. How to draw the structure of complex ion? Okay, here is the step. Okay, in order to draw the structures of complex ion. Okay, the first one, we calculate the oxidation state of central metal first. Okay, and then we write the electronic configuration of central metal. Okay, and then we write the orbital diagram of central metal. Okay, number 4, we prepare the empathy orbital. Okay, in a central metal to accommodate the lone pair of ligand. Okay, how many ligand will be enter the central metal? So we must prepare the empathy orbital. Okay, and then we determine the shape according to the hybridization involved. Okay, and don't forget that the formation of bonding in complex ion is depends on the strength of ligand. Okay, depends on weak field ligand and strong field ligand. Okay, let's say if you use a chloro as a ligand, so we must do not pair up the electron in central metal. Okay, why if you use like ammonia? Okay, ammonia is a strong field ligand. Okay, because nitrogen. So we must pair up first the electron in central metal before we added the ligand, before we accept the lone pair by ligand. So now here is the example of complex compound that I want to show you. So example 1 until example 5. Okay, now let's enjoy the video.
Okay, now I want to show you how we write the formation of complex compound. Okay, now the given is the anionic complex. Okay, the first thing is since this is from the coordination of 4. Okay, so which is it have two shape. Okay, maybe it will form tetrahedral shape. Okay, or it will form square planar. So it depends on the ligand given. So according to the notes, so chlorine, which is halogen, halogen is categorized as a weak field ligand. Okay, so this is a weak field ligand. Okay, so for weak field ligand, so you must memorize that it cannot pair up. Okay, let me show you. Okay, so the first step here is you must calculate the oxidation number. So copper plus 4 negative 1 equal to negative 2. Okay, and then copper equal to positive 2. So the oxidation state of copper here is positive 2. Okay, now what is the atomic number of copper? So copper have 29 atomic number. So let's write the electronic configuration of atom. Okay, so we have so copper atom here. So copper atom, argon. Okay, so 4s, 18, 4s1 and 3d 10. Okay, so this is the electronic configuration of copper atom. Okay, so since this involve of copper 2 plus, so copper 2 plus ion, so the electronic configuration will become 3d 9. Okay, we already removed 2 from here. Okay, so it left 3d 9. Okay, so now let's draw the oxidation, the orbital diagram. Okay, let's draw the orbital diagram of copper ion. Okay, so now we have copper. Okay, we know that it have 1, 2, 3, 4, 5. Okay, so this is a 3D 10. Okay, which is occupied by 3D 10. And this one is I refer to the copper atom. Okay, so originally, so it have 4s1 here. Okay, it also have 4p actually, but 0 electron. Okay, so now when it become copper 2 plus, so it become 3d 9. Okay, so ini I fill up first forgot. Okay, so just fill up 3d 10. Okay, and 4s1. Okay, now 3d 9. Okay, so 1, 2, 3, 4 and 5 here. Okay, so Okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and it also have 4s, but for S0. Okay, also it have 4p. Okay, but 4p is 0 electron. Okay, alright. So now, okay, copper 2 plus is readily to bonded with ligand. Okay, so it readily to accept the ligand here, which is this 4. 1, 2, 3, 4. Okay, so it have 4 ligand will be entered into the central metal. Okay, which is in to form dative bond. It means it will prepare the empty orbital to accommodate the ligand. Okay, so now is what happened. Okay, what happened is, so now we already have, okay, so this one is remain. Okay, remain. Okay, remain. Okay, so this one is 3D9 remain. Okay, and then, okay, for 4S. Okay, and then also for 4P. Okay, so it will enter the chloride ion here. Okay, chloride ion will be accommodated here. Okay, which is, okay, it will form dative bond. Okay, dative bond. Okay, dative bond and also dative bond here. Okay, so got it, So what happened is, okay, so this shape, okay, what is the orbital involved here is, okay, 1s. So we have 1s orbital and 3p orbital. So it have sp3 orbital. Okay, so for sp3 orbital here, okay, the shape is tetrahedral. Okay, tetrahedral shape. Okay, so now we can draw the structure. So we have copper, okay, and we have dative bond here. Okay, the ligand is chlorine. Okay, and then chlorine. Okay, also we have chlorine and chlorine. So this is the tetrahedral shape. Okay, and then it have 2 minus here. So this is the structure of the ligand. Okay, so the shape is tetrahedral. Okay, shape tetrahedral. Okay, so what is the name? Okay, so we have tetrachloro. Okay, tetrachloro. Okay, this is the anion. So copper become cuprate. Okay, and the oxidation number is positive 2. Okay, so this is the name. Okay. Alright, so the first question is done. Now let's write down the formation complex of second complex, which is also an anion complex here. Okay, so we have NiCN4. Okay, so the ligand type, so for Cn. Okay, so for Cn, okay, refer to our notes that for carbon, nitrogen and phosphorus is a strong field ligand. So it is a strong field ligand, which is for strong field ligand, don't forget that we must pair it up. Okay, the electron must pair up, okay, before we enter the ligand. Okay, before we put the ligand in the orbital, so the electron in nickel in central metal must be paired up first. Okay, let me show you. So for the first one, okay, we write down the oxidation state of nickel. Okay, which is nickel, okay, plus 4, negative 1, cyano is negative 1, okay, equal to negative 2, okay, and then nickel, okay, equal to negative 2 plus 4, so equal to positive 2. So the oxidation state of nickel is positive 2. Alright, so, okay, how about the nickel proton number is 28. So let's write down the nickel atom. Okay, the electronic configuration. Okay, so it have argon. Okay, and then it have 4s2 3d8. Okay, so since it's involved of positive 2 ion, so Ni2 plus. So we must write down as argon 3D8, since we already removed the outer electron. Okay, positive 2. Okay, we remove the positive 2 electron. Okay, now let's withdraw the orbital diagram here. So for nickel 2 plus, so for nickel, okay, for nickel 2 plus. Okay, so just draw. Okay, 1, 2, 3, 4, and 5 here. Okay, so we have 3D 8 here. Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. Alright. Okay, and then we also have 4s orbital but 0. Okay, and then we also have 4p. Okay, 4p 0 lah. Okay, they have no electron in the orbital. Okay, now. Okay, since this is the strong field ligand, so we must pair up the electron. So make sure this electron must be paired up. Okay, so what happened is, okay, it will form like this. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So it become like this. So once, okay, it become like this because it's already paired up. So it left one empty orbital in 3D. Okay, and then we have 4SO here. Okay, and then we also have 4P lah. Okay, then, okay, now we want to bond it with 4 ligand. Okay, 4 cyano will be entered into the empty orbital. Okay, so, okay, we must use 1, 2, 3, and 4. So 1, 2, 3, and 4 here. Okay, so we will use 4 empty orbital to put the 4 ligand here. Okay, so what happened is, so now we draw the orbital here. Okay, now we have, okay, so we have 3D8 orbital which is already fully filled. Okay, 3D8, and also we have 1, 2, 3, 4. Okay. Okay, 4, 1, 2, 3, 4. Okay, orbital which is, okay, this involve of 3D, 4s, and 4p. So we call as a DsP2 because we use 2 empty orbital of p. So this hybrid orbital we call DsP2 orbital. So, okay, so we just left 1 4p lah. Okay, 1 4p 0 we left. We didn't use. Okay, so now is, so this empty orbital is will accommodate by cyanide. Okay, Cn ion. Okay, will enter into the orbital. So it will, okay, put the lone pair here lah. Okay, 1 Cn consists of 1 lone pair. Okay, and then 1 lone pair, 1 lone pair, and also 1 lone pair here. So, okay, we then draw the orbital diagram. So, what happened is, refer to our notes. So, this kind of orbital, the sp2 is a square planar. Okay, square planar shape. Alright, so now let's draw the structure. So we have Ni as a central metal. Okay, and then just put Cn in square planar shape. Okay, so Cn here. Okay, Cn. Okay, and Cn. Okay, so 2 minus. So we can conclude that the shape, okay, of the structure is a square planar shape. Okay, so what is the name here? Okay, so we have tetra 4Cn. So we have tetra cyano. Okay, this is anion. So nickel convert into nickelate. Okay, and the oxidation state is 2. So just put 2 here. Okay, so we done. Write down the second question. So that's why you must memorize the field ligand, strong field ligand and weak field ligand. Now let's draw the third complex, okay, which is it have hexa, it have 6 ligand. Okay, now, okay, we calculate the oxidation state first. So cobalt, okay, plus 6. Okay, this is a neutral ligand, so 0 equal to positive 3. Okay, cobalt equal to positive 3 oxidation state. Okay, so cobalt, okay, which is have a 27, okay, proton number. So the electronic configuration of cobalt atom is 18. So we have for S2 3D7. Okay, so in this complex it's involved of cobalt 3 plus. So electronic configuration, okay, so it become 3D because we already removed the 3, 3, 2 and 1 from 3D. Okay, then, okay, the category of the ligand here. Okay, so we have ammonia. Okay, so ammonia, okay, ammonia ligand is included in a strong field ligand. Okay, because N, nitrogen. Okay, so it is a strong field ligand. So make sure that you pair up the electron in cobalt. Alright, okay, now let's draw the orbital diagram first. Okay, now we have 3d6. So 3d6, so cobalt 3 plus, you have 3d6. Okay, 1, 2, 3, 4. Okay, it have 3d6. Okay, and then it also have 4s. Okay, but 0. Okay, and it also have 4p. Okay, 0. And it also have 4d. Okay. Okay, so 4d, 0. Okay, so it have 3d6. Okay, so just put electron here. Okay. Okay, 6. Okay, now. Okay. Okay, refer to the orbital diagram. So don't forget that the ligand involved is ammonia. Okay, so we must pair up the electron in the cobalt ion. Okay, so okay, let's pair up. Okay, so this one is pair up with this. So what happened is already pair up. Okay, so 3d6 will become, okay, 1, 2, 3. Okay, so it already pair up. Right, so it left 2 empty orbital here. Okay, then I redraw the 4s. Okay, I redraw the 4p0. Okay, also 4d. Okay, 4d0. Okay, now, right, we will use the 4 ligand. Okay, we will bonded with the 4, bonded with a 6 ligand. So we will use 1, 2, 3, 4, 5. Okay, 6. Okay, 1, 2, 3, 4, 5 and 6. So this 6 empty orbital, okay, will be accommodated by 6 ammonia. Okay, so okay, what kind of hybrid orbital will be formed is, okay, the hybrid orbital will be formed is like this. So we have 1, 2, so 3d6. Okay, fully filled of 3d6. Okay, and then the hybrid orbital is, okay, we have 6. Okay, 1, 2, 3, 4, 5 and 6. So this kind of orbital is involved of d orbital, involved of s orbital and p orbital. Okay, so now we have d2, s and p3. So d2 sp3 is a kind of hybridization. Okay, so now we will bond it with ligand. So ligand, so we put ammonia here. Okay, each empty orbital will accommodate by ligand. Okay, so just put here. Okay, so one ligand which share is lone pair will be share. Alright, so this is the diagram. So let's draw the structures of the complex. So from our note, we know that this hybridization is represent the shape of octahedral. So this is the octahedral shape. Okay, so let's draw the structure. Okay, so now we can draw. Okay, so we have cobalt. Okay, cobalt, and then okay, ammonia. Okay, ammonia. Okay, this is the first axis. Okay, and then we have okay. Okay, NH3. Okay, and then don't forget the bracket. Okay, bracket. Okay, and then charge 3 plus. So this is the structure, okay, of the complex. So the name, okay, is hexaamine. So shape, okay, shape involved is octahedron. Okay, so what is the name of the complex? So we have amine, hexaamine. Okay, and then cobalt, because cation, just use the same name. Okay, cobalt. Okay, positive 3. So 3, 1, 2, 3. Okay, so 3. So hexaamine, cobalt 3. Now we have the fourth complex. Okay, complex ion. Okay, which is cation complex. So if you can see that the ligand involved here is a bidentate ligand. So this one is a bidentate ligand. Okay, involve the bidentate ligand, which is it will donate 2 lone pair. Okay, so basically it will form like this lah. Okay, because it involve ethene diamine. So ethene diamine. So we have NH2 diamine. So it have a lone pair here kan. Okay, so ini it will donate lah. So it will donate. So this lone pair will be donate to the central metal. Okay, so let's draw the complex. Okay, so we start by calculate the oxidation state first. Copper, okay, and then plus. So this is the neutral bidentate. So 3, 0 lah. Okay, equal to positive 2. Okay, and then copper equal to positive. So copper is equal to positive 2 oxidation state. Alright. Okay, then next step, okay, as usual, we just put the proton number, which is copper have 29. Okay, so the electron configuration, we have 4s1, 3d, 10. Okay, so it involve copper 2 plus, so the electronic configuration will become 3d9. Okay, 3d9, so we remove 2 electron. Okay, then okay, we draw the orbital diagram here. Okay, we draw the orbital diagram. Okay, F3D9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and then 4S. Okay, empathy 4S. Okay, and then empathy 4P. Okay, also empathy 4D. Okay, empathy for the orbital. Okay, so now, okay, so if you can see that, okay, for bidentate ligand, it have 3 bidentate, so it represent 3 times 2, so it have 6 lone pair. So it means that the central metal must prepare the 6 empathy orbital in order to accept the lone pair from ligand. So now we have 1, 2, 3, 4, 5, 6. Okay, so this empathy ligand will accommodate 6 lone pair by ethylene diamine. Okay, so it will form, okay, what kind of orbital, hybrid orbital form here? Okay, so we have 6. Okay, so it have 4s. So we have sp3d2. So sp3d2 hybrid orbital form. Okay, okay. So it's this one is a remain lah. This one is remain. Okay, remain s3d9. Okay, so now, okay, let's draw the diagram here. Okay, now, okay, we have copper. Okay, we have copper. Okay, and then we have 3 bidentate ligand of ethylene diamine. So, start here. CH2. Okay, and then NH2. Okay, NH2. Okay, so this content of lone pair, okay, donate to copper. Okay, donate to copper. Okay, this is one by the. Okay, then we have second ligand here, CH2, CH2. Okay, and then we have okay, NH2 amine. This one is the amine. Okay, so then lone pair in N donate to copper. Okay, so we have 2 ligand. Okay, 2 of bidentate ligand. Okay, and then the third ligand. Okay. Okay, then donate the lone pair to the copper. Okay, now, okay, it's diagrams. Okay, looks like chelating lah, chelating compound. Okay, now just put the bracket as a complex and put the charge. Okay, so we have done. Draw the structure. So let's we put the okay, the shapes. Okay, so the shape involved. Okay, so refer to our chem book. So sp3d2, okay, or sp3d2, okay, okay, or ni we call as a octahedral shape. Okay, so this is a octahedral shape. Okay, octahedral shape. Okay, and then name. Okay, let's name. Okay, so how to name it? Okay, it have ethane 1, 2, so we use tris. Okay, tris, ethane. Okay, 1, 2. Okay, diamine. Okay, diamine. Okay, and then the central matter is the copper. So we must draw, okay, copper. Oxidation state 2. So 2. Okay, so the name is tris, ethane 1, 2, diamine, copper 2. So now we have done, okay, the fourth question. Okay, the last question here is compound involved of EDTA as a ligand. Okay, now we draw the chemical formula of EDTA first. Okay, so EDTA, so it have ethylene diamine. So CH2, CH2, and N. Okay, and it's a lone pair here, So it have tetra acetate. Okay, tetra acetate. So it have CH3. Okay, C double bond O and O minus here. So lone pair here. Okay, and then CH3, C double bond O, O minus. Okay, lone pair. Okay, and then this side, left side. Okay, CH3. Okay, C double bond O, O minus. Okay, lone pair. Okay, and then CH3, C double bond O, O minus. So this is the EDTA formula. Okay, now how to draw the structure, okay, of complex of EDTA, nickel EDTA. Okay, so now, okay, we write down the, okay, we calculate the oxidation state of nickel first. So nickel, okay, plus, so EDTA is a negative for oxidation state. Alright, okay, and then equal to negative. Okay, so nickel is positive to oxidation state. Okay, now, okay, we take a look the electronic configuration of nickel. Okay, no, and nickel have a 28, 28. So it's okay, 3D8 and 4S 2. Okay, so ke 28. Okay, and then it involve of nickel 2 plus. So okay, so the electronic configuration become 3D8. Alright. Okay, so now we draw the orbital diagram. Okay, orbital diagram. Okay, orbital diagram, it have 3D8. 3D8. Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. Alright. Okay, and then it also have 4S 0. Okay, empty orbital. Okay, and then also have 4P. Okay, also have 4P and then 4D. Okay. Okay, so for D0 for P0. Okay, so now is since the EDTA is hexadentate, means that it consists of 6 lone pair. So the ligand, which is the 6 lone pair from EDTA, okay, we use 1, 2, 3, 4, 5 and 6. So we use 6 empty orbital from the nickel ion, okay, to accommodate to form dative bond. So, okay, what kind of hybrid orbital form here? S, okay, P, 1, 2, 3, sp3 and D2. Okay, sp3 and D2 hybrid orbital. Okay, so we will accommodate 1, 2, 3. Okay, so 1, 2, 3, 4, 5 and 6. Okay, 6 of sp3 D2 orbital. So this 3d8 is remain lah. Okay, TD8 remain. Okay, so 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so now, is, okay, so every empty orbital, okay, with 6 lone pair of EDTA. Okay, we put in each empty orbital of nickel ion. Okay, so now, okay, let's draw. Okay, so before that, we know that from this kind of hybridization orbital is we form octahedral shape. Okay, now, okay, let's draw the EDTA complex. Okay, bonded with nickel. Okay, so nickel here. Okay, nickel. Okay, and then, okay, let's draw the EDTA. Okay, so for EDTA, okay, we starting draw for ethylene amine first. Okay, so ethylene amine first. So we take one part. So CH2, okay, N. Okay, this one is N. Okay, so lone pair in N, okay, will donate to nickel. So 1 and 2 here. Alright. Okay, so this one is one part. Okay, one part. Okay, and then, okay, for this N, it consists of 2 acetate. Alright, 2 acetate bonded with one N. Okay, so this N will have, okay, 1 and 2. Alright, so this one, it have CH2, okay, and C, double bond O, and O mine. Alright, and same goes to this side. This side also have CH2, okay, C, double bond O, O mine. And we know that this O consists of lone pair. So we donate, okay, the lone pair to the nickel. Okay, 1, and from here 1. Okay, right. So this is the structure. Okay, the first the structure, okay, of the nickel. For this is the right side, okay, of nickel. Okay, now we done right at the right side of EDTA. Alright, so now I continue for the left side here. Okay. Okay, and then for this side, okay, okay, now we have, okay, this N also bonded with, okay, another CH2, okay, and then C double bond O and O mine. Okay, O mine here. So this O mine, okay, will donate its lone pair, okay, to the central atom. Okay, right, and then, okay, it also have another acetate here. So CH2, okay, bonded to, okay, to C double bond O, okay, and O mine. So this one will donate to central atom. So this is the structure, okay, of the nickel EDTA compound. Okay, then finally just put the bracket. Okay, put the bracket. Okay, and then 2 minus. Alright, we have done draw the compound of EDTA complex. Okay, so now this is also the chelating compound. Alright, now, okay, what is the shape? Okay, so the shape of this complex ion is octahedral. Okay, so the name. Okay, the name. Okay, so this is the EDTA is not follow as we do before. So we call this compound as a nickel 2-EDTA complex. Okay, so actually is this EDTA. Okay, alright, thank you.